Hello, everyone. Thank you for joining us for this 4 p.m. Thursday session, and welcome to SEC222 from Code to Cloud, building AppSec programs with AWS. My name is Daniel Begimer. I'm a senior security engineer in AWS. Been here for over 5 years now. Been doing security for the past 13 years across different domains, including incident response, application security, and recently GenAI security. Today, I'm here with Patrick Go.
Hello, everyone. Patrick Gall. I'm a principal security engineer on AWS's global service security team. And I've been at AWS about 3.5 years. Prior to that, I was a late stage startup where I was a VP security. I helped build up their greenfield security program. And then prior to that, I was an AppSec engineer and have built and run security engineering teams and architectures. And pleasure to meet you all today.
Cool. So this is a level 200 breakout session. We're going to have 60 minutes where we're going to dive deep into AppSec, how you can build AppSec programs in your organizations. Hopefully by the end of this talk, you're going to get some tools, practical tools, practical frameworks that you can go and implement in your environments, regardless on which stage you are in your AppSec program, if you already have one or if you plan to implement a new one. We're going to start by having a quick overview about what is application security. What exactly means AppSec? What is an AppSec program? Then we're going to discuss the principles of AppSec. And from there, we're going to dive deep into the AppSec program roadmap. And we categorized it to 4 different phases. We're going to start with preparation and planning, which metrics you need to define, which metrics you need to collect, how you're going to communicate with different stakeholders in your organization whenever you implement new AppSec controls. Then we're going to touch execution. We're going to show you how you can really run threat model, how you can run code scanning, and other AppSec solutions leveraging our services. And we're also going to show you some demos there. And in the end, we're going to touch on scale, how you can do those things in scale. And I really hope this session will be valuable and helpful for you. Patrick.
Thanks, Daniel. So before we get to the main part of the session, I'd like for us to align on a common understanding of what application security is. So application security is a set of people, processes, and technologies used to evaluate the security properties of software during all phases of the software development lifecycle. So I'll call special attention now to the latter part of that definition, because it gives some unique insight into how AWS views application security and security. It's really along 2 dimensions. First dimension is around this notion of ownership or distributed ownership. So if you talk to anybody at AWS, from Matt Garman, the very top, to individual contributors, they're going to tell you security is top priority. That's the first piece. And so implied in that is some notion of distributed ownership. Everybody at AWS that builds and operates services has some sense of responsibility and accountability towards securing the services that they build. And so part of that as well too, in particular, our builder teams, when they build and operate a service, they're responsible for the security of their service. But they're also empowered to make security decisions on behalf of AWS. So that's the first thing, is distributed ownership. The second dimension is around this notion of shift left, or integrating good security practices across the entire SDLC. So if you asked me about AppSec 10 years ago, we'd have done bolt-on security after the fact, after we push code to production. Today we think about integrating good security practices as early on as possible into the SDLC. So you all have probably heard the term shift left, right? So it's distributed ownership to scale. Second thing is around integrating good practices, security practices, as early on in the SDLC. So Daniel's actually going to touch upon a core mechanism that we call threat modeling. And we'll get into details and give you a high-level framework and approach to do that. But that's a core part of what we do here at AWS. Now, why is it important? If we're doing it right, then we're really helping our builders build software faster. get features and capabilities into your all hands as quickly as possible while still maintaining a high bar for security. And if we think about integrating all these application security best practices early on in the SDLC as possible, you're also reducing costs and reducing risk for your organizations. Because let's face it, it's a lot easier to actually make changes on a simple diagram in an architectural diagram than it is to actually go back and roll back code that's insecure to start with, and then also potentially deal with the fallout related to having security issues potentially being exploited. And if we have those time savings, those cost savings there, we have more time and we have more money to reinvest into our program for other improvements. Now, how do we do it? There's really 5 core principles that we here at AWS abide by. First is around setting clear expectations. From an organizational perspective, it's really understanding what your risk tolerance is as an organization, what your risk appetite is. Defining what that security bar looks like. Once you define that, then we clearly define what security requirements, policies, and standards we're going to drive and enforce across our AppSec program, across our portfolio of applications. Earlier, I also mentioned this notion of like distributed ownership, right? And that service teams at AWS that build and operate their services, they're also responsible for the security of their services. We empower them with knowledge, so having a strong training mechanism to educate them on knowledge of security. And it's also teaching them things like threat modeling. So a lot of our builders, as part of our standard development processes, are looking at architecture diagrams, and Daniel's getting into more details, but they're going to identify risks early on in design and try to build in security versus wait for after the fact when code is pushed to production. So the second core principle is really around having robust training communities around empowering our developer teams to actually build securely. Third part is automation. We use automation to be able to automate undifferentiated manual processes, 1. And then 2, when we define security requirements and standards and policies, we use automation to consistently apply them and enforce them across our SDLC. Now the 4th is around metrics. At AWS, we consistently measure everything. So think of metrics in terms of number of security flaws, by severity levels, by different business units, business lines, because that gives us a current view of what our security risk posture is, and then also gives us the basis for continuous improvement. So the 5th one you also heard a little bit about earlier too is this notion of organization. And when I say organization, I mean organizational buy-in across the entire org. Now, I mentioned earlier that everyone from Matt to individual contributors like myself, for us, security is top priority. And so that's key. The other aspect of this underlying these are the 5 key principles that we use to drive our program. But the other underlying principle that I'll show you next is just based on my own past experiences. So a number of years ago, when I took on a new AppSec team and had to reboot the program, we had to get some visibility out there to understand where our security risks were within our application portfolios were going to be. And so we evaluated a number of different application security platforms to be able to do things like static analysis, security testing, software composition analysis. And one of our core requirements is really how effective the SAST and SCA engines were going to be. What I didn't consider, and looking at it back at it, hindsight is 2020, is really, is this tool something that the developers going to actually use? And so it was a hard lesson learned for me. And so when we deployed this platform, we selected a platform, we deployed it, and it took probably 3 times as long as it should have. But the problem was, I was asking our developers to go and actually do the build and the compilation to build the software, and then log into a separate platform, upload that to actually get the scans done. And that was a struggle. I planned out a year in terms of planning. It took 3 years to actually get 100% coverage and 100% visibility of security risks across the application portfolio. That lesson learned translates into this last principle. And you'll see this theme throughout in that we want to give developers an easy button. So my lesson learned was we want to, as we think about our AppSec programs, whether we're building a greenfield one, we're rebooting the AppSec program that we currently have, we really want to meet developers where they are. Which means things like we're not going to add extraneous process into what they're doing, right? In terms of tool selection, in terms of how we communicate, we really want to give them the easy button. And you'll see that across a variety of different dimensions, whether it's technology or even just simple communication. So a lot of this is sort of my own personal experiences, but there's actually a branch of science called behavioral economics. But the TLDR out of those studies is that humans are inherently lazy. I am inherently lazy. If I was given a choice to take action or not taking the action, I would rather not taking the action. That's just what it is. And so as I think about AppSec and as we think about AppSec, we really need to drive this home, make it easy for them. So in terms of a practical roadmap, there's nothing fancy here. AppSec and getting behavioral change to occur it's not rocket science, really. It's not a technology problem. It's not as much a technology problem as it is a human organizational change management problem. And so we want to keep it simple for you all, in line with the spirit of using the easy button. It's 4 phases. And you can use this whether it's a greenfield or brownfield program you're trying to reboot, but planning, preparation, execution, and scale. And we'll dive into each 4 of these throughout the remainder of the session. So in the planning phase, it's really about stakeholder analysis. It's identifying and engaging your stakeholders, understanding who they are, what their businesses are, keeping the business objectives in mind, because we as a security team really want to be a business enabling function versus a traffic cop in the solution. So it's identifying and engaging stakeholders, understanding the high level risks, understanding what keeps them awake at night. And then from there, it's working with them to establish clear goals and metrics that we can measure and that we can achieve. From there, it's about preparation, getting code scanning across your environment, across the portfolio applications, to understand what sort of security risks you have in your source code, in third-party packages. And then we talked about communicating your expectations. It's really defining what your risk tolerance is, and then defining those standards, requirements, and policies, and then communicating those expectations with those stakeholders. And third piece is around scale, training builders the threat model. There's never going to be enough AppSec engineers to support the number of developers. Having been one before, it's impossible. Even if I work 24 hours a day, 365 days a year. And so we want to really empower our builders, train them on security, 1, and then 2, we want them to identify risks in their design and build securely versus wait till after code is pushed to production. In the execution phase, that's where we're sort of in a steady state. We actually have threat modeling as a standard part of our design processes. We're finding and fixing security issues in the IDE before a line of code ever gets committed into our source code repositories. And it's also deploying security testing in pipelines, knowing that we want a defense in depth approach to applying controls. And lastly, scale. Once we've got the visibility, once we have an ongoing process whereby we can actually see what the security risks on our applications are going to be, then we can start looking at identifying systemic issues. And then turning around and building secure design patterns, enabling our developers by giving them what we call golden path design patterns, packages. So for example, one of the things at Amazon we do is we want to give our customers a consistent authorization experience. So we have a golden path pattern for that, and we also have auth libraries and packages that we all use as part of that design pattern. And that's how we can start thinking about scale. And lastly, it's really about seeking feedback from your program stakeholders, really understanding who your stakeholders are, having a good relationship with them, right? Getting to instead of saying no immediately, it's really about how do we get to a secure yes. So let's dive into the plan phase. So I mentioned briefly earlier, it's really about identifying and engaging your stakeholders. Take inventory applications, understand what you're working with to start with. Understand who those owners are, who the businesses are, and then also understand the operating context. But the biggest pro tip I'll tell you here is, if you're rebooting a program or you're building something greenfield, getting leadership buy-in is going to be the most important thing. And second thing is, find AppSec-friendly or security-friendly organizations, leaders, to help you create some quick wins. Engage with those organizations, find applications that we know that are high risk, high value, high impact if we were to help there. Get some quick wins, get some momentum, and that really starts to accelerate your program after that. And then most of all, it's really about reframing your thinking. And we'll see some of those examples and just subtle communication differences. But again, meet developers where they are, not the other way around. understanding high-level risks. When we do the stakeholder analysis, we really need to understand the applications we're working with, the business context, the operating context. Get a complete view. Some businesses are going to have different objectives than other business units that you support. So having understanding of those subtleties is going to help you build rapport, build trust, build relationships with your constituents. Because you're going to need that, because you, as an AppSec engineer, are never going to be able to scale yourself as a human. So you need their help. Understand their priorities. Ask them what keeps them up at night. What are some of the challenges? And then from there, think like an adversary at a high level. Look at different business lines, maybe in different industries potentially, depending on the size of your company. And understand what the potential avenues that a threat actor would like to compromise either confidentiality or integrity or availability of your systems. Lastly, this is not rocket science. It's really just doing basic things like establishing clear goals and metrics and getting everybody aligned. So out of this plan phase, you want really to develop a program charter. You want to get buy-in with the leaders at the highest level. When you're rebooting a program, whenever you're building a greenfield program, you really want to bring your stakeholders along as part of that journey. You want to include them in the conversation. You want them to be involved in the definition in terms of the program vision, mission, and charter. And that way they have some sense of ownership and accountability. Once you do that, get some quick wins, then you start to get some momentum, and then you really start to take off. Key is distributing ownership. So back to the initial concept of everybody at AWS owns security, right? Our service teams are responsible for and accountable for not only building and operating their services, but operating and being responsible for security. Now, out of the planning phase, you get a charter, you've brought your stakeholders along, you've got a clear vision, mission, and goals, you've got buy-in from the leadership perspective. Now it's about preparation, getting visibility of your portfolio. Get testing out there. Understand what sort of security issues are in your source code. What third-party packages are most vulnerable. Try to identify systemic issues, and then develop mitigations for high-risk, high-impact applications. So this is kind of interesting. Now we sort of switched to the communication aspect, and we talked about this notion of the easy button, right? And so I like to use this framework called the EAST model. And so when we start to engage our stakeholders, we communicate with them. It's really about, when we think of communication, think of 4 letters, E-A-S-T. Keep it easy. Make it exciting, make it attractive, right? Gamify it. Make it social. It's funny, there's this psychological phenomenon called social proof. So in the absence of, if you're presented with a situation where you're unfamiliar and you don't know what to do, the human tendency is to look towards your peers to see what they're doing, what they're thinking. And then you have this tendency to do the same things that they do. And so you'll see it in the upcoming example of sort of reframing and how we communicate that actually drive a lot of behavior change. And part of that is the social proof concept. You'll see it sort of in practice in the next few slides here. And make it timely, right? Read the room. As you communicate, it's being able to understand when's the best time to talk to somebody, right? Try to identify barriers to action or inaction and remove them. But it all goes back to the easy button. You can use this EAST model in your communications as you engage with the stakeholders. So going back to my story of my lesson learned when I was deploying this AppSec platform, and we'll call it a AppSec widget. This looks like probably 80% of your corporate communications that go out. It's not quite as long, but if you read it, take a moment to read it, it's kind of boring. But the thing I'll call attention to here is that bold line. Action required. Enable scanning in respective source code repositories by a certain date. So we're deploying an AppSec platform. We want developers to actually start scanning their applications so we get some visibility out there. So 80% of boring, asking you to take a lot of actions and making it hard, right? To me, that's a barrier of action, or a barrier to actually doing something. So that's what I probably would have written 10 years ago when I was trying to reboot this AppSec program. Now let's think about the EAST model in the context of this next email. So I'll give you a moment to sort of read it, but a couple things to call out here. The first one is this notion of making it really easy. So if you see the call to action, we're actually using defaults, if you will. So if you need to opt out of scanning for specific repositories, following exception by January 31st, 2026. So we're by default enabling scanning on repositories so we can get some visibility out there, and we're not asking a lot of our developers. So we're actually forcing them to opt out of it, and it makes it easier. So subtle reframing techniques make a huge amount of difference in terms of the way you communicate, the way you collaborate with your developers. And you also see things like the first one, the first bold line. In fact, 90% of builders who tested it thought it was easy. That's the power of making it attractive. Like, you want to gamify it, you want to make it exciting, you want to show that most developers are actually doing this and thought it was a cool, really cool and easy to use platform. And so subtle reframing, as you can kind of tell in the way you communicate, makes a world of difference. So now, we've talked about the communication piece. We're going to move to the execution phase. Daniel?
Thank you, Patrick. So really, we started with the prepare and planning phases. And now we'd like to discuss how you're really executing, how you really can leverage frameworks or some of our services in order to run the execution for your AppSec program in your organization. Let's start with threat modeling. You want to threat model everything. Whenever if it's a new feature or a new product, you want to start by trying to understand what can get wrong. What's the worst that can happen? So when you start the threat model, there are several phases that you can follow and several frameworks, and I'm going to share some shortly. But first, your goal is to try to identify those risks earlier as possible during your software development lifecycle. If you need to make a code change, or if you need to change the architecture, or include different service or tool, you want to make those changes on the whiteboard and not already after the application is developed and deployed. Now, this is an example for a framework, the 4 showstack 4 questions framework. Whenever you run threat model, you can leverage that or other frameworks out there. But the principles are pretty simple. You're going to start by, what are you working on? If it's a new service, it's a new app, it's a new feature, an existing service, who is our customers? What is the business logic? What exactly is the expected outcome? Next, it's what can get wrong? What's the worst that can happen? If I have an unauthorized user, if they can exfiltrate sensitive information, they can maybe impact the integrity of my data. What's the risk of the availability if my app won't be available for several hours? And what is the business outcomes of that? Then what we're going to do about it? Which tools, which services we can implement in order to mitigate the risk? Maybe we can use a different software package, or maybe we can push a code change. So what exactly we can do in order to mitigate or minimize the risk? And in the end, we need to review it. We did a good job. Like, if we really minimize anything that we wanted to mitigate, if we accepted some risks, if we can accept the current state of the application. And this process is iterative. So you will probably learn from other applications, you will learn from other projects, you will learn from your security issues. So you need to take those learning outcomes and put it again as a part of this threat modeling process and make sure you're asking the right questions. Now, this is how we also work in AWS. Whenever we're shipping a new product or a new feature, a new service, threat modeling is something essential that needs to work a part of this process. If you want to take another step further about what exactly you need to do when you threat model. So first, make sure you have diagrams, documentation, that you know what is the data flow, what is the architecture. If you don't know how the system looks like, how you can threat model it, right? Next, you need to get your security teams, your developers, and your business stakeholders all in the same room or virtual room, and work together in order to identify the risks and different mitigations. Then we need to document, as we mentioned before. We want to document everything. And you can really use some tools. One example for a tool is Threat Composer. It's a tool which is available as an open source tool in our GitHub repository. I will share a link later on. But the idea is it can help you to conduct this process and really document the information and the decision that you make during your threat model. Next, I would like to discuss another topic, code scanning. You want to scan your code, your repositories, run software composition analysis. I assume most of your teams are leveraging AI tools as well for development. So we are going to really discuss Amazon Kiro and the Amazon Inspector, and how those tools can help you to run some of those AppSec processes. Let's start with Kiro, our agentic IDE solution. This is an example for the easy button that Pat mentioned earlier. So really, Kiro can help your builders, your developers to write code to be more productive, and we know that by now. But it can also help you to run code scans, perform security testing, security analysis on your code. And it really meets the developers where they are, right? Talking before about the easy button, developers using IDEs to develop code. So why not including those tools as a part of the IDE to make it easy for them, and not adding another process or another screen or another window that they need to open in order to follow an AppSec process. Next, I would like to show you Kiro in action. I would like to have like a short demo about how you can leverage Kiro for AppSec. Just before jumping into the demo, I have a quick question. Who likes French fries? Raise your hand if you like French fries. All right, I like French fries. Probably need to eat less, but I'm really a big fan. If I want to be a security engineer, I'm probably gonna be. I will probably open my online shop for French fries. So that's what I did with this demo. You can see here Fry Factory, my online shop for selling French fries. And I have different types of French fries here. You can see that we have classic fries, but we also have cheese fries. Truffle fries are my favorite, actually. And this is an AppSec talk. So if we will go to the My Order section, we can see that with a simple SQL injection query, I can potentially get some sensitive information. So this is very sensitive information about the previous orders, the amount of salt, the amount of crispiness, how much ketchup each previous order had. So this is something that I probably would like to investigate and protect. Now let's jump quickly into the source code. This is Kiro, the IDE that I mentioned. And if I will go to the source code of my Python app, I can see that I'm using Flask, and I have several dictionaries that represents my database. And if you notice downstairs, down there, like there is some hard-coded credentials as well. So I think that by now we all agree this app is a bit vulnerable. Now I can use Kiro and just mention those issues, or ask Kiro to run a security scan for me, and that's fine. But I want actually to show you something a bit from a different angle, a bit more advanced. I'm going to use the Kiro steering documents. So the Kiro steering documents can help me to define prompts, which can include standards or security requirements or templates, and I can reuse them across different projects or across my organization. So if I would go to the Kiro folder, and I will go to steering, and under steering I can see different files. So first I have a file that can help me to define my documentation standards, how documentation should look like, right? This is how I want every project documentation to be structured. There's another example of threat modeling. We just discussed threat modeling, how you can automate that. So really here I can use the Stride, and I want to have these risk scoring metrics with these considerations, with this template. Another example I want to show is security standards, which may be the most relevant for this one. So I have here a document that defines my security standards. If you notice, section 2 and 3 are directly relevant to the security issues that we noticed before. We have secrets management, which we know that we're not really storing secrets in a secure location. We saw the hard-coded credentials. And also the injection prevention, which we saw an example of how we can really run SQL injection against our sample app. So this steering document can be ingested into Kiro, and it will help me to run the fixes. Great. I want actually to take it a step further. I will use Kiro agents. So Kiro agents can help me to define different agents with different roles, that the input of those agents can be those steering documents. We can see here that we have a threat modeler agent, conduct the threat modeling using Stride. Your role is to analyze the application and identify the security issues. And really, you have the which paths are allowed for these agents, which actions this agent can take. And I'm also ingesting, as a resource, the stem string documents that I showed you earlier. So this can really help me to just run threat modeling in an easy way. Let's jump to our security scanner. I have another agent that's specialized on running security scans. And this agent, again, has the prompt. You're running SAS scans, and you need to run security scans again against the projects. And I'm also ingesting the same resources that I mentioned before, but this time I'm also including a tool. I'm including Ash, the automated security helper. So you can integrate with the agents your own tools in order to run your security operations. Ash, in this case, is the code security scan tool that's available in our GitHub as an open source. And again, I'm going to share the link for this one as well. But the idea is just to show you that with the power of Cura agents and MCPs, you can really create end-to-end integration with your business context, the security standards, security requirements, your project, and really the role and the prompt that we're running into our agent. Let's see how it looks in action. I'm going to call our agent to run a security scan. So since it already has the context, I don't need really to provide any additional guidance. We're just going to go to the Cura CLI. And I will call our Cura CLI security agent, which I've defined here. The MCP is loading, and I'm running a security scan with a simple prompt of run a security scan. And this will take a couple of moments, and eventually the scan will run, and it will trigger my tool, follow my security standards, follow the guidance of the agent, and it will provide me a contextual security report based on the finding that it found in the repository, based on what my tool found, based on whatever I prompted and in the security standards and instructions. So we can really see, again, the secrets management and the SQL injection. Next, I want to really take it to I can just like open the report and review it and share it with my developers, or my developers can review it. But we can even take it to even one step further, and we can use Kiro, again, to take this report and give us specific actionable actions that we need to run against our code repository. So by running that, again, it's gonna probably take a couple of moments. Oh, sorry. It's going to take a couple of moments, but in the end, I can see really a report with what exactly are the issues, what needs to be fixed, and how I can really implement it. So this really connects to the same easy button that Pat mentioned before, and it's kind of, we're going to repeat this concept. Make sure you're making it easy for the developers. I want to show another example for another easy button, another tool that can help for running AppSec on your org. This time it's Amazon Inspector, our vulnerability management tool. Amazon Inspector can integrate with the different AWS accounts and run scans against your containers, against your compute resources, against your code repositories. And it's really an easy button because, again, you're not asking anything specifically from your developers. You can integrate Amazon Inspector with your GitHub and GitLab repositories and have this centralized visibility over security issues across your organization. Let's see it in action. So here I'm in the Amazon Inspector console, and I can just go to code security. I've already integrated Amazon Inspector with my GitHub repository, really with a couple of clicks. And I'm going to just create a new scan configuration. There is some parameters that I can change here, such as how often I want the scan to run. I'm just leaving it default here. It's going to be weekly, and on every commit, push to main. And I can also pick the different security scans. So I'm going to leave it as infrastructure as code scanning, static code analysis, and software composition analysis. I can really filter by which repositories I want to run the scan against. Just going to run it against all of them. Now, in this case, it will just run on the next weekly period. I think that here I picked Monday, so instead of waiting until next Monday, we can just run an on-demand scan. And after running an on-demand scan, a couple of minutes later, I can really go into my scan, and I can see a full detailed report of my security issues. Since it scanned both the code and both the packages, I will find different types of findings. Here we see, again, example for hard code credentials. What exactly is the issue, and how it can be fixed. Then we have another example for another package vulnerability this time, and which version will be fixed in this specific case. So really, Amazon Inspector is a very easy to use tool that hopefully can be beneficial for you as well. After we really discussed about some execution steps, we showed you how you can use Kiro and Amazon Inspector. We discussed threat modeling, how we can really scale, right? We can, of course, scale with Amazon Inspector and Kiro as well, but I want to dive deep into the scaling mechanism. First, and I think that Pat mentioned it a bit before, we want our developers to think security. Here in AWS, developers focused on shipping and delivering new amazing features and products, but they all think in security. They all have security in mind. They can measure those security. We have different programs around secure development, which I will share in a bit. So make sure that your developers are aware to the importance of writing more secure code, and make it easy for them. Make it easy for them with different tools, with automations. And make sure you're not adding another step and making it hard to write a more secure code. One example, if you have a solution or a process that the developers needs to follow, where it's reusable, maybe create a reusable artifact that they can consume. For example, if you have standards for how authentication should work in your organization, instead of trying to invent the wheel each time, make sure you have a package for authentication that they can just consume, import to their project, and it already have the security requirements and standards that you need to follow. If you know how a 3-tier web app should look like, give them a reference architecture. Give them the infrastructure as code templates. Give them already an environment built in with those security controls, so it will be easy for them to start building. And another point is make sure they have the autonomous to make decisions. Make sure your security teams make sure your developers teams, not always rely on the security teams, which are centralized and can be a bottleneck, right? So we really want to make sure that we can let our development teams, the product teams, the builders, to make security decisions. And I'm going to give an example here as well. So in AWS, we have the Guardians program. Anyone heard about the Guardians program before? Okay, we have one hand. So the Guardians program is a program that we have internally. We already have some public resources about as well. But we're taking developers, builders on the different product teams, and we're training them on security. And they're acting as the security guardians of the team. Those team members knows their teammates best, knows the product best, understand the business goals of their team, but they also trained on how to really do security and how really to conduct threat modeling and how to really follow those centralized security team with the security requirements. That really helped to expedite security and AppSec processes. Because those security guardians helping the product team to run the threat model, helping them to guide documentation, helping them to implement security controls. We still have a centralized security team. We still need to run a penetration testing and to get the sign-off from the centralized security team. But when you have that security guardian in your team, it really helps you to make sure that you get everything necessary and we really make this process more smooth. So we really touched the different phases of how you can really build an AppSec program in your organization. We started with planning, right? Pat really showed you some examples of how you can define goals, define metrics, how it's important in order to measure success before you even start to run the program, define what success looks like. Then the preparation, how you communicate to the stakeholders, how you train the teams. We saw the example of the email, how changing a couple of words and sentences making a huge difference, right? Then we discussed execution. We saw the threat modeling, which questions you need to ask, what do you need to collect, how you can use hero steering documents, how you can use inspector integration with your code repositories. And then we discussed scaling. We talked about making reusable artifacts when possible. We talked about the Guardians program. We talked about distributing ownership to your product teams. Now, if there is one big takeaway that I want you to take from this talk, is make it easy. Don't make AppSec hard on your teams. Integrate it with your processes. Make sure it's easy for your teams to run the code scan and to get you the result to make sure that you follow the security requirements. Try to work backwards from your development teams and integrate in your security requirements and standards there. I promised you some resources. So those are some resources that we discussed today. You can check the threat modeling workshop if you want to dive deeper into how to conduct threat modeling. We have the Threat Composer, the open source tool that I've mentioned before, which you can use in order to run the threat modeling against your applications. Ash, Automated Security Helper, it's an open source tool for code security scans, and I showed an example with the MCP and agent. And the Security Guardians blog if you want to hear more and learn more about the Guardians program. I really hope this session was helpful for you. We're going to stick around if you have any questions, and please fill out the survey. It's super important for us. Thank you so much.